In this video, we're going to start out with air quality improvements. So, the Environmental Protection Agency and state agencies monitor these 6 criteria pollutants that we talked about in the last video, and then we study how they're the risk to human health and assess for plans. Each pollutant has an ambient air quality standard and set the maximal allowable concentration for each pollutant in the air. 4 of the 6 include carbon monoxide, sulfur dioxide, and particulate matter, and lead. So, nitrogen dioxide, for example, is a highly reactive reddish-brown, foul-smelling gas that contributes to smog and acid precipitation, or acid rain. Tropospheric ozone, or O3, is also called ground-level ozone. It's a secondary pollutant, so it's not created directly by an industrial source, but it mixes with the air and then creates created by the reaction of nitrates and volatile organic compounds in sunlight. Ozone is unstable. It can injure human tissue and it can cause respiratory problems. More than 4,000 monitoring stations take hourly or daily air samples. This is used to calculate a general air quality index on a 0 to 500 scale as far as health of the air for that day. And so in places like LA, where there's a lot of smog, there may be places like an immune compromise or people with respiratory problems won't go outside because of the air quality index is high that day. So overall, the criteria concentrations on the ambient air across the U.S. has fallen steadily since 1980 because we're measuring them, we know what we're looking for, and we've set standards for industry. While most urban areas violate at least one ambient air quality standard, we have seen a general improvement. So you can see some of the most dangerous areas have been the traditional Rust Belt, and that's an area like steel factories and heavy industry there. They just have a lot of processes that create a lot of toxic chemicals. And then Los Angeles, for vehicles for the most part. You can see everybody was high in 1985, and everybody's much, much lower in 2015. So these standards and these laws make a difference. So, and it's important that we control these because they are public health risks. They can cause cancer, they can cause reproductive defects that can be passed on to next generations, neurological development impairment, immune system impairment, respiratory problems, and not just people but other organisms. So things like mercury from coal-burning power plants, volatile organic compounds from gasoline, and methylene chloride found in paint stripper, these are all things that need to be regulated because of their toxicity. Rural areas also confront pollution changes from places like airborne pesticides from farms. So some of the most in danger are the people that work with it on a day-to-day basis and a lot of times cannot afford protective gear when they're spraying pesticides. But then there's industrial pollutants that can drift very far from distant cities. We're seeing like a concentration and biomagnification in the regions where the polar bears are, and then they have such high fat content that they can store all these in their body. It can cause incredible damage even though they're very, very far from any industry themselves. So methane, hydrogen sulfide, and ammonia from animal waste in large feedlots can become a problem, and we've got hundreds of animals unable to get it all off site safely, and the environment just can't clean it fast enough because there's just too many creatures there. And then fumes from natural gas extraction sites, and not just the fumes for air quality, but remember with the solvents that we looked at with fracking, can ruin air quality and water quality and soil quality for centuries. Air pollution remains severe in industrializing nations. So areas that we talked about where they're able to build power plants and use automobiles, but they don't have the money to buy to buy like things like scrubbers for their smokestacks and their coal, or to buy high quality engines that have catalytic converters. And then a lot of times people use wood and charcoal and coal for cooking in home heating, and we're going to talk about indoor pollutants here shortly. Many power plants and factories use outdated, heavy polluting technology because it's cheaper and it's quicker to build. So for example, Beijing in 2013 The pollution came so severe that flights were canceled and people wore face masks to breathe. On a air quality index from 0 to 500, they read up to 755. So you can see the long-term illnesses are incredible. You can see the haze in the background, and they're kind of in a pocket, similar to LA and Mexico City, where the air comes in and it just sits there because they're in a valley. And then there's a lot of heat there, so that it just stays. Pollution levels are even worse in cities in India, such as Delhi and other Asian metropolises. According to the World Health Organization, or WHO, survey 13 of the 20 most populated cities on Earth are in India. So you can see, growing up in this area, the long-term health effects, the short-term health effects can be profound. So smog is a general term for a mix of air pollutants that can accumulate as a result of fossil fuel combustion, especially over areas with heavy automobile traffic. Cities suffer from a specific type of smog called industrial smog, which lends to the fact that there are other types of smog we're going to look at. So industrial smog contains carbon dioxide, carbon monoxide, mercury, and sulfur from burning fossil fuels. And then that sulfur especially can react with oxygen and water, form sulfuric acid in the atmosphere, which we know is acid rain. America's worst industrial smog event occurred in Donora, Pennsylvania in 1948. Because Donora is in a valley, and that can trap air, and it traps smog from a steel and wire factory for days. And then we talked in another video about the killer smog in 1952 that can kill between 4,000 to 12,000 people. Incredibly dense, and all from industry. We'll pick up with smog in the next video.